All right, guys. So today, what we are doing is we are continuing to talk about writing exponential equations. So we're taking a lot of the points that we talked about yesterday and building on it. So yesterday we talked about writing exponential equations from tables and graphs. Today we're going to be talking about writing them from 2 points, whether they flat out give you the 2 points or you get them from a word problem. That's what we're basically focusing on today. Now, pretty similar processes to yesterday with how you find the different parts of the exponential equation. All right. So we're just going to go ahead and jump right into it. So if you guys need to turn the light off, go ahead and do that. So we always start with our I can statement, which is I can write an exponential growth Oh Lord, nope. I can write that's tomorrow's, my bad. I can write equations. This is what happens when Miss Murphy reads the wrong one. In exponential form given 2 points or two ordered pairs or a word problem. So again, very similar to what we did yesterday. It's pretty much the exact same processes. There may just be one more step involved. So let's do a little review. So remember, this is typically the way we write exponential functions. So f of x is equal to a times b raised to the x power. What did I say the a value represents? What key feature does the a value represent? It's the y-intercept. So your a value represents your y-intercept. So whatever number that's being multiplied to your base, that's your y-intercept. And I pretty much answered B myself, and that's the base. Now, I failed to mention yesterday another name for the base, which you may also see it as the common ratio. Because if you think about it, it's basically the number that you're multiplying from your y values to get to the next one over and over again. So that's why they call it the common ratio. Now, remember, depending on what type of number your b value is, depends on whether your graph is increasing or decreasing. So just to review, if your b value is greater than 1, is your graph going to increase or decrease? It's going to increase. Now, if your graph is between 0 and 1, so in other words, it's a fraction, a true fraction, what happens to your graph? It decreases. And remember, you are not going to get a negative base. All right, your a value may be a -1 or a negative number, but your base will never be negative. It's going to be positive. All right. Now, we're going to do some examples with going from two ordered pairs. So, very similar to yesterday, you first want to determine which value is the easiest to find, your A or B. For example 1, which one do you think will be the easiest to find, A or B? A. Why do you think A? Not necessarily. It's the y-intercept. So we're given the y-intercept right here at 0, 6. Remember, if you have an x value of 0 and then y is some other number, you got the y-intercept. So my a value is what? 6. So that means my function will look like y is equal to 6 times some b value raised to the x power. So now we need to find our b value. Now, It may seem like it's a complicated task given that we only have 2 points and not a table or a graph, but it's actually about the same process as if you're finding it from a table. So what I'm going to do is I'm going to make my own table. So I'm going to have x, y, and I'm going to list the points in numerical order of x values from least to greatest. So I'm going to put 0, 6 first. Now leave some space between 0, 6 and the next point, and I'll show you why in a second. And then I'm going to put 3, 48. Now, there's a reason why I left space here, and we'll talk about that in just a second. So let me ask you this. What do I need to add to 0 to get 3? 3. So we're adding 3 to get from 0 to 3. So in other words, we're going in 3 steps. Now, remember what I said about tables yesterday. So typically, if we were trying to find the base from the table, what were we looking for? Who remembers? So we're trying to find the b value from the table. What were we looking for? So look back at your journal from yesterday if you need it. What were we looking for when we were going from the table to give us the b value? What typically gave us that b value? Look back at the problems from yesterday. How do we do it? How do we get our b value from the table? Multiply what? It was the number that we multiplied from one y to get to the next y value. Now, what was very apparent about those x values? How are the x values going up in those previous tables? So if we look at the previous tables from yesterday, so like these two, look at the x values specifically. What are the x values doing? They're going up by 1. Now that's very important. If they are not going up by 1, you have an extra step when you're trying to find your base. All right, because our next instinct here would be to find what number we can multiply to 6 to get 48, which what is that number? 8. So we would times it by 8. Now, 8 is not our base because 0 to 3 is not a 1-step increment. It's a 3-step increment, which means that we have 2 other numbers on both sides that need to be filled in order to find our base. So let's say we had 1 and 2 here. That means that on our x values, we're adding 1 to get to each value. Which if you notice, that still gives us plus 3 in the orange. So guess what? On the y side, we're going to multiply the same number 3 times, and that would still give us multiplying by 8 to get from 6 to 48. So in other words, we're trying to find a number, so these blanks are the same number, that when we multiply that same number together, it would give us 8. So in other words, if I'm multiplying the same number 3 times, what am I doing to that number? So if I'm multiplying the same number by itself 3 times, what am I doing to that number, Elise? We're cubing it. So in other words, and let's call this b, we're taking b cubed is equal to 8. Now, recall back to last semester when you guys did Pythagorean theorem and you would get something like x squared equal to some number. What would you typically do to undo the square? What undoes a square? So in other words, if I told you to solve for x and you had x squared is equal to 16, what would you do next? You would square root it. So a square root undoes a square. You guys know what undoes a cube? Not a square root. So guys, this is new for you. There are several different types of roots. Square root is the most common, but you can take the root of any exponent as long as the root matches the number in the exponent. So we're going to actually take a cube root of both sides. So it's basically a radical symbol with a little 3 in the upper left-hand corner. Now, a cube root is very similar to a square root. All it does is it undoes a cube. So anything raised to the third power, a cube root can undo. And guess what? Your calculator does it for you. So with your TI, all right, we're going to take the cube root of 8. So everyone open up their calculators and follow along. So you're going to need to know how to do this. Just clear it because you want to know how to do it.
I know. Do you know like second?
Nope. So your first instinct would be to hit second and then the x squared button and get that square root symbol. Do not do that. A cube root and a square root may share a radical symbol, but they are not the same thing. There's a way that you can get a cube root to input into your calculator. So the first thing you're going to do is you're going to hit that math key underneath the alpha key, and you'll get this screen. So it's the same screen that you get when you're trying to convert a decimal to a fraction. Now, does everyone see number 4 where it has a little radical and a little 3? This is the cube root symbol. So click number 4 on your calculator, and it will input a cube root into your calculator. So if it does not have this little tiny 3 in the corner, it is not a cube root, it's a square root. All right, and they're completely different. They undo different things. And then we're just going to type 8 underneath it and hit enter. So what's the cube root of 8? 2. So that means that b would have to be equal to 2. And let's check ourselves. That means if we do 2 times 2 times 2, is it true that we get 8? Yes. All right. Now let's check ourselves on our table by finding the 2 missing numbers on the y's. So in other words, we're going to be multiplying by 2 3 times to get from 6 to 48. Let's see if it works. What's 6 times 2? What's 6 times 2, guys? 12. What's 12 times 2? What's 24 times 2? 48. And we end up where we want to end up. So my suggestion to you is check it to make sure you got the correct b value. So in other words, my b value, my b value is going to be 2. So this 2 is going to be my base. So my equation is going to be y equals 6 times 2 raised to the x power. So the main process for this is write your points for b value specifically. Write your points in a table. Figure out what you need to add to your x values to get between your two x values. And that's actually the increment or the type of root that you will use to undo however you get from your y values by multiplying. So in other words, if we're adding 3 to get from 0 to 3, that means we're going up 3 steps, which if you look over here, what we multiply to get from 6 to 48 is 8. But since we went up in an increment of 3, that means we need the other numbers. So we have to take the cube root of this number that we get from multiplying 6 to 48. Take the cube root of that, and that will give us our base value, which is the number that we multiplied 3 times in order to get this 8. Does everyone understand that process? Yes, no, maybe? All right, let's try another one. So 2 is a little bit easier in terms of finding the b value. So for this one, I would find the b value first. Why would I find the b value first instead of the a value? So think about what the a value represents. Why would it make sense to find the b value first over the a value, Elise? Well, the x's go up by 1, but what's also the major kind of thing going on there? What does our a value represent, guys? The y-intercept. Did they give us the y-intercept? No. So the only way we can find our y-intercept, if they don't flat out give it to us, is if we have our b value, and we can either work backwards to find the y-intercept if we have our b value, or we can solve for a, but we still got to have our b value first. So if they do not give you your y-intercept, you've got to find your b value first. So we're just going to do the exact same process. So we're going to find what our b value is equal to. So we're going to draw our table again. Now, I'm going to leave a little space above the 1 because we'll work backwards to get to y-intercept. So I'm going to do 121. Now, we all know that 2 comes after 1, so we don't have to leave any space between the two. So 2, 147. So this b value is pretty easy to find because it's similar to how we found it yesterday. Because what do I need to add to get from 1 to 2? 1. So then, basically, since we're only adding 1 to get between those two x values, whatever number I multiply to get to between my two y values will be my base value. All right? So how can I figure out what I need to multiply to 21 to get to 147? So how do I find how to get from 21 to 147? What's the fastest way I can... Right, just we do the opposite. We divide the two numbers. So we're going to divide 147 by 21, and you should get 7. So we're multiplying by 7. So my b value is what? 7. Now, that means that from the parts that we have so far, we got y equals a times 7 raised to the x power. So now we need to find our a value. So recall, your a value is your y-intercept, which means that you have an x value of what? What's always your x value for a y-intercept? I heard it. 0. So again, there's two ways that you can do this. You can either work backwards using your table and what your base value is, or you can plug in one of your given points and solve for a. Either way works. In this case, brute forcing it and working backwards is actually easier. So because we have an x value of 1, that means 0 is just one place backwards. So that means to get from the y value connected to the 0 to the y value of the 1, we have to multiply by 7. So how do you think I'll get my y-intercept from the 21? What do you think I need to do, Elise?
Divide 7.
Right. Do 21 divided by 7, which will give you what? 3. So that has to be our y value when x is 0, because 3 times 7 is 21. So that means my a value is what? 3. So now I got all my pieces. So y is equal to 3 times 7x. Now, one thing that I failed to mention with the first problem, if you ever have a doubt in your mind, and this is in the calculator active section, plug this into Desmos. So plug your equation into Desmos and plug your 2 points into Desmos and see if the line goes through them. If they do, you are correct. So let's do a quick check here. So if I open up Desmos, I'm going to put in y equals 3 times 7 raised to the x, raised to the x power. And then in a different spot, I'm going to type in my first point, so 1, comma, 21, and my second point, so 1, not 1, 2, comma, 147. Now, you may have to zoom out a little bit. So, there are my 2 points and my line. Do those 2 points go through the line that we created? Yes, they do. So we can assume that we came up with the correct equation. All right. So if you ever have doubt, that's just a quick check that you can do. It's correct if it goes through both points. If it doesn't go through both points, you probably did something wrong. Does that make sense? All right, let's look at the next one. So this one looks difficult because there's a fraction, but it's actually not that bad. So first things first, what do you think is the easiest to find? My A value or my B value here? A. Why A? Because they gave us our y-intercept. Yeah, I know. Whenever they roll things outside, it's loud. So they gave us our y-intercept, which is right here. So that means our A is equal to what? 100. So that means I have y is equal to 100 times some b value raised to the x. Now, I'm going to make my table to find my b value. So I have x, y, I have 0, 100. Now, since our next x value is 3, I'm going to leave some space between the two x values. So then I put 3 and then 4/5. Now, let me ask you this. If the x values increase, but the y values are decreasing, is our graph going to be increasing or decreasing? Decreasing. So what should we expect our b value to be? What type of number? A what? A fraction. So we should expect it to be a fraction because this graph is decreasing. If we don't get a fraction, we probably did something wrong. All right. So let's just go through the steps that we did in example 1. How do I get from 0 to 3? What do I need to add? 3. So my guess is that we are going to be taking a cube root somewhere. Now, how can I figure out what I need to multiply to 100 to get to 4/5? What do you think I'm going to do? Divide. So I'm going to divide 4/5. I'm going to do 4/5 divided by 100. So you always do the y value connected to your larger x value divided by the y value connected to your smaller x value. All right, and you can just put that right into your calculator. So I'm going to type in 4 divided by 5 in parentheses because that represents 4/5. Then divided by 100. Now we get a decimal, but I want a fraction. So how do we convert a fraction in our calculator? I heard it. What do we hit first? Math, and then we hit enter twice. And we get 1/125. Now, that seems like a very small fraction. But remember, is that going to be our base value here? So Aiden, just grab your new journal and just hop into the lesson. Behind you. Just hold on to it for right now. All right. So that may seem like a small fraction. However, is that going to be what our b value is equal to? So is 1/125 our b value? Yes or no? No. Why is it not our b value? What did I say our x's have to do in order for it to be our b value? our x's have to increase by blank in order for it to be our b value. 1. So if I increase my x values by 1, so I fill in my remaining x values, that means I have 1, 2, 3 steps to get between my x values. So that also means I have 1, 2, 3 steps to get to my y values. So what do you think I'm going to do with that 125? So in other words, if one step for the y values, let's say it's b, that means if we do the same number, so or b 3 times itself, what do I have? B raised to the what? So it's the same number multiplied by itself 3 times. So we have b cubed. And b cubed will be equal to 1 over 125. So how do I undo a cube again? Not a square root, a cube root. So we're going to take the cube root of 125. And again, your calculator can do that for you. So remember, hit math, then 4 to get that cube root, and then type parenthesis 1 divided by 125, close the parenthesis, and hit enter. Now, it's still a decimal, so we want to change it to a fraction. So again, hit math and then enter twice, and we'll get 1/5. So I'm assuming that my b value is going to equal 1/5, meaning over here, I'm going to multiply by 1/5 to go down the line of my table. So we're going to check ourselves and see if we got the correct term. Now, if we multiply a number by 1/5, what's that the same thing as dividing by? So we multiply a number by 1/5, then we're technically dividing by what? Not 2, 5. If we're multiplying by 1/5, we're technically dividing by 5. If we multiply by 1/2, we're dividing by 2, 1/4, 4, 100, 100, so on and so forth. So what's 100 times 1/5? So again, you're dividing by 5. So what's 100 divided by 5? 20. So this would be 20. Then what's 20 times 1/5? 4, because you're just dividing 20 by 5. Then what's 4 times 1/5? 4/5. So does our base value work? Yes, because it gets us from where we started to where we finished. So that means my b value is truly 1/5. So here is my equation. And again, don't trust yourself. Plot it in Desmos really quickly. See if that line goes through both points, which in this case it will. Any questions on examples 1 through 3? So I will say in the next example, we may have some, we'll have like a bigger interval than a cube. It'll be a 5th. So we're still going to do that example, but just know on your test, I won't give you an example, a question where you'll have to do more than a cube root. All right. You'll most likely be asked to do either a square or a cube. All right. I won't make you do anything higher than that, but I'm still going to show you how to do it because you can still do it in your calculator. All right. So those are when we're just given the points with no context. Now look at example 4. So example 4, we're getting a word problem. All right, we all love word problems. So about the value of a brand new, stop moving. The value of a brand new 2020 Ford F-150 truck in 2020 is $38,540. In 2025, that same truck, so it's still a 2020 truck, is worth $24,190. Now, we're then going to write an exponential model to show the value of the truck after t years. So think back to first semester. When we're talking about t or time, what value does that typically represent, the x or y value? So when you think time, it's typically your x value. So in this case, t is going to represent our x value, which means the amount of the truck would be our y value. So years is your x, the amount is your y. So let me ask you this. Let's try and figure out what our x values are for these 2 points, because they did give us 2 points here. They're just not ultra obvious. If you buy a brand new truck in the year that it was made, so 2020, and you bought it in 2020, how many years have gone by? So from 2020 to 2020, how many years have gone by? 0. So that means for 2020, my x is 0. Now, you still bought a 2020 truck, but in 2025, so how much time has gone by? 5 years. So for this one, my x is equal to 5. So that means for my 2 points, one of them will have an x value of 0, the other will have an x value of 5. What's my y value that goes with my 0? What y value, or the amount of money of the truck, goes with when x is 0? So when x is equal to 0, how much money is the truck worth? What's it saying the problem? $38,500. That's my y value. Or $38,540. So after 5 years, what's my y value? Not for 24. I thought you said 34. So this will be 24,190. So guess what? There are my 2 points. Now I got to find a line between them. So in this case, is A value the easiest to find, or the B value? A, because we're given that y-intercept, which is right here. So since this is our y-intercept, which, by the way, y-intercepts also deal with your initial or starting value. All right? Since that's my y-intercept, that's also my A value. So A is equal to what? $38,540. So that means I'm going to have y equals 38,540 times some b value raised to the x. So I still need to find what my b value is. And to do that, we're just going to do the same process that we've been doing. So I'm going to make a table. So I'm going to make a table, x, y. I'm going to put 0 and then 38,540. Leave a bunch of space. And then 5, 24,190. So we first need to figure out what we have to add to get between the two x's. So when I go from 0 to 5, what do I have to add to 0 to get to 5? 5. So since we're adding 5, that means that we're going up in increments of 5. Now, what do I need to multiply to 38,540 to get to 24,190? How can I find that? How have we been doing it? So I'm just going between 38,540 and 24,190. What do I need to multiply to 38,540 to get to 24,190? So remember, you would do 24,190 divided, or no, backwards. Right. It'll be a weird decimal, but it does convert. So if you do 24,190 divided by 38,540,
1.5936.
not quite. So if we did the 24,190 divided by 38,540, we get a really weird number. Hit math, enter, enter. It still gives us a semi-decent fraction. So 59 over 94 is what we're multiplying by. Now, given how many steps we are away from 0 to 5. So remember, if we filled these in, between 0 and 5, we have 1, 2, 3, and 4. So we have 1, 2, 3, 4, 5 steps. That means on the flip side with the y's, 1, 2, 3, 4, I have to multiply the same number 5 times. So 1, 2, 3, 4, and 5. So if I'm multiplying the same number 5 times, so let's call that number b. That means b is raised to what power if we're multiplying by itself 5 times? The fifth. And b to the fifth should equal 5994. So let me ask you this. How do I undo a fifth? I gave you a hint, very similar to a cube root and a square root. Yes, a fifth root. So there is such a thing as a fifth root. So basically, like I said, any exponent with a number, so a numerical exponent, you can undo with that same numerical root. So again, square root undoes a square, cube root undoes a cube, fourth root undoes a fourth, fifth root undoes a fifth. It all works out. So this will take the fifth root of both sides. So it's going to look like a little square root, but with a mini 5 in the corner. And again, your calculator can do it for you, but it's a slightly different process than the last time. So in your calculator, all right, first thing you want to do is type a 5. That represents the fifth of your fifth root. So just type a 5, nothing else. Then, once you type that 5, you're going to hit math. Now, the only definite root that it gives you besides a square root is a cube root. However, do you see number 5 below the cube root where it has a little x and then that radical symbol? That's the button that you click to create whatever type of root you want. So the reason we put the 5, we already typed the 5 is because we want to go ahead and make sure that this x is going to be a 5 because that will symbolize the fifth root. So I'm going to hit 5 in math, and now we have a fifth root. So this is now a fifth root. It has that little 5 and then the radical. And then I'm just going to type in the fraction that I got. So parentheses, what was it, 59 over 94, right? So 59 divided by 94. And I'll tell you right now, this ain't going to be a pretty number. And I can also tell you that if you did math and enter, it still doesn't give you a fraction. It's just an ugly number. So in this case, we're going to round. So I'm going to say round to the nearest hundredth, which means we're rounding to how many decimal places? So to the nearest hundredth, that's how many decimal places? 2. It's 2 decimal places. So if I round to 2 decimal places, what's my b value? 0.91. All right. So that means that b is equal to 0.91. Now, we're not going to check it because we did do some rounding, so our numbers will be off a bit. But as long as you did your calculations correct, you can have some faith in that. So our b value is going to be 0.91, which means this is our equation that we're going to use to model the value of the truck after t years. Any questions on how to get that equation. So again, I will rarely give you something where you have to take like a really big root, like a fifth root, sixth root, whatever. I only expect you guys to know how to take a square root and a cube root in this context. All right, so you just need to know how to do those two and you'll be fine. That was kind of a one-off thing. Now, let's answer some more questions. So, based on this exponential model, what is the predicted value for the truck in 2028? So, in other words, how much will the truck be worth in 2028? First off, if we're talking about 2028, would that represent an X value or a Y value? X, because we're talking about time or years, because 2028 is a year. Lord, I'd be 28. Oof. Now, we know that X is not the actual year number. In this case, X would be what? So remember, we started in 2020. So in this case, X would be what? X would equal what? How many years have passed from 2020? 8 years. So 8 years from 2020. So X is equal to 8. So how do you think we're going to use our equation that we found in the previous to find the value of the truck after 8 years? What do you think we're going to do? So we know that X is equal to 8. What do you think we're going to do? We got the function, we got the X value. So what do you think we're going to do? Guys, if we're given an X value and a function, what do you typically do with that X? Not multiply.
Subtract.
It's no operation. So guys, if I ever throw a definite X value at you and I give you an equation with that X in it, where do you put that number in? In the X value. We're going to plug in the 8 for the X. We're evaluating. So this would be Y equals 38,540 times 0.91 raised to the 8th power. We replace the X with the 8. And guess what? You can just put this straight into your calculator to get an answer. So in your calculator, we're just going to type it in. So 38,540 parentheses 0.91 raised to the 8th power. So type it in exactly as you wrote it and hit enter. So we get this. Now, I'm going to say since all the other numbers are to the nearest dollar, we're going to round to the nearest dollar as well. So if I round that answer to the nearest dollar, what would that be? So think about it. Will you have any cents if I round to the nearest dollar? No. So that means the decimals will be gone. So if I want to round to the nearest dollar, what's my answer? Good, 18,124. So I would get Y equals $18,124. Don't forget to put your units. So after 8 years, oh my goodness, I hate it when it does this. So after 8 years, that's how much the truck will be worth. All right, last one. So, in what year would the value of the truck drop below $8,000? So, in other words, they want us to find the X value. Now, that means this 8 grand is your Y value, and they want us to find the X value because we're talking about what year. Now, you could solve this equation. However, that is a Math 3 concept. But we can figure this out by using our calculator. So your calculator is your friend for this one. You will not see a problem like this on the calculator inactive section of your EOC. It will always be in the calculator active. Because again, solving exponential equations, you won't do until Math 3 because the the method to solve that exponential equation. You just won't learn it till math 3. All right. So essentially what we're going to do is we're going to look at our table in our calculator. So we're going to look at the table in the calculator. All right. So to get that table, you're in your calculator, you're going to hit y equals in the upper right hand or upper left hand corner. And you're going to type in our original equation that we found in part A. So 38,540 times 0.91, all raised to the x power. So remember, your variable key is right next to that green alpha key. So take a minute, go ahead and type in that function and stop there. Don't hit anything else. Now, once you get here, we only want to look at the table. We don't really care about what its graph looks like. So we're going to hit the second or that blue key in the top left corner. So second, and then you're going to hit graph, which is the top rightmost key. So hit second and then graph, and then your table shall generate. So I'm looking for when the y value start going below $8,000. The first y value that goes below $8,000, that x value is our answer. So use your arrow, up and down arrow keys, and just keep going down your table, because remember the x values are increasing, so just keep going down and look at the y values and stop when you see the first y value below 8,000. So the first y value below 8,000 is what you're looking for. So once you do that, how many years have passed? 17. So 17 years have passed. However, that is not our answer. Why is 17 not our answer? What our problem asked for, Christian? It said what year, not how many years. So it wants to know what year, so the actual year that this value will be under 8,000. How do I figure out what year it is? 17 years later. Well, how do I do that math? So where do I start? Where was my beginning year? 2020. So I would just add 17 years to 2020, and that would give us our new year. So in this case, it would be in the year 2037. So guys, make sure you read those problems very, very carefully, because they will try and trip you up like that. That's where I see a lot of kids get problems wrong. They don't read the problem exactly, and they'll say that the answer is 17. Well, you would only get partial credit for that on a test because it asked for the actual year. All right, so make sure you read your problems very, very carefully. All right, so I want you guys to try out that last example on your own. I will post the answer to it in a little bit. Now, once you finish that, there is a new Delta Math. It combines what we learned yesterday and today. That'll be due tomorrow by midnight. There's also packet work for this lesson. It's pages 15 and 16 in the packet that you got from yesterday. All right, so take a minute, work out that problem in your journal first. I'll give you guys about 10 minutes to do that. Then I'll post the answer. And then as soon as you finish that problem, start working on your Delta Math or your packet work. Does everyone understand what they're doing? All right, get to work. And can someone cut the light back on?